Hi, welcome to the video on training the model. By the end of this video, you will be able to build linear regression model using Scikit-Learn, make predictions for test dataset and evaluate model performance on test dataset. Let's continue our discussion on implementing linear regression. Now that we have scaled our dataset and removed the multicollinearity, we can focus on training our model. We will start by dividing the dataset into train and test set. As we have already seen this before, so we will skim through it. First, we will replace the set of independent variables x with the new VIF data, and our target variable is y, which we have already declared before. In the next cell, we divide the dataset using the train_test split into x train, x test, y train, and y test. And on checking the dimensions of the resultant partitions, they are consistent with each other. Now we move on to the main part, which is the implementation of the linear regression. For implementing the linear regression, we will be using the Scikit-Learn library. This allows us to implement the linear regression model in few lines of code rather than defining our own gradient descent. So we will start by importing the linear regression class from sklearn.linear_model. After that, we create an instance of the class linear regression and set the parameter normalize as true. This will normalize all the independent variables such that linear regression will no longer need to find out the value of intercept. In the next line, we use a function with the help of linear regression instance as lr.fit, to which I am passing my training data x train and y train. This lr.fit function is the one that implements the gradient descent and the complete procedure over the training dataset, which comprises of the x train and the y train. We know that the gradient descent finds the best set of parameters to model the data. So let's see that. Using the lr.cof_ attribute of the linear regression class, we can see all the coefficients corresponding to the independent variables that our linear regression has calculated. These coefficients are nothing but m1, m2, m3, etc. that we had seen in the equation of a multiple linear regression before. Please note that since we have normalized the data, this means the value of the intercept m0 would be 0. Now that our model has been created, we will now generate the predictions over the test set. For this, we again use the LR instance of the linear regression class and use the predict function, and inside the function we've passed the test x, which represents the independent variables of the test set. Now let's run this cell. Now the generated prediction are stored in the variable predictions. Now let's evaluate the predictions generated by our model. For this, we use the LR instance of the linear regression class and call the score function. I'm passing the whole test dataset into this function, which are X test and Y test. This core function calculates the R-square value of the model we have created. So let's run this cell. The R-square result is 0.846 and this is a respectable score considering it is a linear regression model. And that's it about the model implementation. Using Scikit-Learn library makes it very easy for us to implement the complex models using just a few lines of code. Now that we have implemented the model, we will verify a few of the assumptions of linear regression for this model that we have built in the next video.